In this work entitled G-integral computation and limit load analysis of banded composite repair in crack pipes under pressure, an additional criterion was introduced to evaluate the composite repair system using the limit load analysis. Plastic collapse pressure of AP5L steel pressure vessel structure with the crack defect is numerically investigated after the structure was being repaired by composite overlap. Pipeline was meshed using a structured mesh with three-dimensional hexadominated quadratic elements. On the first criterion, the pipeline was subjected to an applied internal pressure of 7 MPa and the longitudinal crack geometry was defined previously. This figure shows the J-integral distribution along the crack tip line 1 for a longitudinal crack for a repaired pipe. We remark that the crack tends to propagate radially more than longitudinally. This figure presents the variation of maximum J-integral value in the crack type line 1 and 2, with the loading pressure for both repaired and unrepaired pipes. Also, we can note that the crack propagation in depth is more dangerous than the longitudinal crack. This is for the repaired and unrepaired pipe. In this part, we summarize an analysis of the overall numerical results. So we have tested the proposed regression equation and validated it with the Excel SATA software. The obtained model provides a coefficient of determination R square equal to 0.97 with 8 degrees of freedom. Finally, the results obtained within the scope of this study enable us to draw the following conclusions. Firstly, a nonlinear proportionality behavior of the value of maximum of G integral with the loading. The crack propagation in depth is more dangerous than the longitudinal crack. The composite overlap reduces the G integral level for a constant value. We note finally, the repair technique elevate our values of plastic limit load independently to the crack geometry.